Morning. Let me see here if I can. Yeah, very good, very good. Okay, so we're off to a wonderful start with a super interesting morning. Thanks to all the speakers for all the wonderful talks. And now we're going to do the fun part of the morning, which is the Levchin Prize ceremony. So just to remind everyone, the Levchin Prize is a prize that actually honors major innovations in cryptography that have had significant real-world impact. It's the only prize that kind of focuses on sort of real-world impact in cryptography. So it's a, I don't know, it's a unique prize in that sense. And so I guess the prize, just to let you know a little bit about the history of the prize was started in 2016. It's named after Max Levchin. Maybe you've heard of him. He's the founder of PayPal and Affirm, and a very, very long-term supporter of applied cryptography. When we reached out to Max to say we want to create an award in applied cryptography, we want the award to be an award of $10,000, he immediately said, yes, I'll support it forever, and that'll be the award. We had to work a little bit harder to convince him to name the award, that we would name the award the Levchin Prize, but it's such a cool name that the name stuck, and so that's what it's called. So he immediately agreed. He will support the award for in perpetuity. It's quite a significant commitment on his part, so we're very grateful that he is willing to do all that. Okay, so the award itself has been awarded, as I said, from 2016. I listed some of the winners, or actually all the winners of this award up until now. It's a very prestigious list. These are folks and organizations who really have had transformative impact on real-world cryptography. So it's wonderful that we can recognize this work and award them the prize. The prize itself, actually the trophy for the prize, is this fancy cryptex. It's really heavy. Actually, if you hold it in your hand, it's a pretty massive cryptex, and in order to get the prize, you have to figure out the key and get the cryptex to open. We used to put the prize in the cryptex, so you couldn't get it unless you actually figured out how to open the cryptex. But we don't do that anymore. Turned out too hard. So anyhow, this is like what the trophy looks like. It's a very, very, very beautiful and impressive trophy. And so with that, let's award the two winners of the 2023 Levchin Prize for real-world cryptography. All right, so our first winner for 2023 is Vincent Rijmen. Can you say a few words? And so, Vincent, the citation is for co-designing the advanced encryption standard, AES. So the initial proposal for AES was called the Rijndael cipher back in 1998, submitted to NIST. In 2001, NIST actually chose Rijndael as the winner of the competition, and it officially became the advanced encryption standard. AES is probably the most profound real-world result in cryptography. I think like a substantial fraction of all of humanity's computing resources is now devoted to computing AES. So it's quite a remarkable cipher and how it's like literally universally used everywhere. But Vincent did a lot more than just AES. I wanted to mention that he also designed lots of other block ciphers, lots of other hash functions, and has also done quite a lot of work in symmetric cryptography as well. So with that, please join me in recognizing Vincent for his amazing work, and please come on stage. Congratulations. And yeah, floor is yours.
Okay, thank you. This prize means a lot to me. There's of course the money involved. There is the nice trophy that will weigh down papers on my desk. And maybe most importantly, I get 5 minutes of your time and you have to listen to whatever I say. Already as a young boy, I was actually always strongly interested in mathematics. However, currently I'm often reminded of a quote by a famous security researcher, Ross Anderson, who said that in any freshly opened research area, you have about 10 years before the theoretical mathematicians move in and take over. And then it's time to leave. You can think of theory of cryptography, practice of cryptography, real-world cryptography. I think this is 12th edition, so you could get scared a bit. However, I think actually cryptography is one of the few research areas where we don't have to be afraid of mathematics. Because, in fact, many mathematicians who thought they were studying quite esoteric concepts, purely curiosity-driven, found themselves suddenly, themselves and their pet topics, at the center of interest of large companies and other organizations doing cryptography. And also, to stay a bit close to myself, I think that one of the reasons why Rijndael was selected to become the AS was because of its mathematical elegance and beauty. Of course, it remains a fact that in many research areas, also in ours, there is a tendency that there are results published that you could call a pity of the silicon that is used to store them. And sometimes it is indeed because the results are maybe theoretically deep, but not about real-world problems. But I think actually more often, the problem is that the results are not significant, also not for non-real problems. And this, I think, is due because of a continuous pressure to publish often and shallow, which is caused by the continuous spreadsheetization of our world. You want to go to a conference, you need one publication. You want a PhD, you need 2 publications. You want funding for a project, you need 5 publications. And I think that's something where we should work on also as a community. And then about the divide between academic research and deployment of crypto in practice, I think the sword is double-edged. On the one hand, there is the ivory tower, where some academicians lock up themselves. But on the other hand, there is also what I would call the swamp of dirty practices. I'm sure all of you who have evaluated commercial products have encountered your share of weak, outdated, incomplete, wrongly implemented or homebrew cryptography. So I accept this prize as a motivation for me to continue working for the development of a real cryptography world. Thank you.
Well said. Okay, so we have one more winner. As I said, when we created the prize, we said initially that there would always be 2 winners every year, and so I'm very happy to announce actually the second winner of 2023. And so the second award this year goes to Paul Kocher in the citation. Can you say a few words? So the citation is for pioneering work on side channel analysis. So Paul actually virtually created the field of side channel analysis. I wanted to just list some of the highlights. So I guess in 1996, he already published the first paper in the area, which talked about time-based attacks and showed all the attacks that are possible simply by measuring the time that a crypto system takes to run. And amazingly, that already is enough to leak the secret key in many cases, or leak other information. He quickly followed up with differential power analysis, which is again a much more powerful technique for extracting keys from protected environments. And this is, of course, he's done a lot of work on both of these areas and others. I wanted to mention the recent work, a more recent work that he did on Spectre, which is basically exploiting or studying the security implications of speculative execution. Again, it was a large team, but you notice that Paul is actually the first author. So amazing set of works, and again, have had tremendous impact on the industry. Before I hand it to you, Paul, I wanted to also remind people that this is not the only thing that Paul did. He also was one of the main authors of a little-known protocol called SSL 3.0, yes, which literally for 20 years or so protected almost all communication on the planet. So yeah, it's amazing impact on the practice of cryptography in the real world. So with that, please join me in congratulating Paul for winning the award. The floor is yours.
Thank you, Dan, and I want to just thank the prize committee for choosing this. There's so much great work out there that I feel kind of embarrassed and humbled to be standing and speaking to you here. And I was trying to think about kind of what to say, and I wasn't sure what to say, and I'm still not altogether sure what I should say, but what I felt was really clear, which was gratitude for the security and crypto communities. And I'm going to start with just a little quick story about how I ended up in this world. So I was an undergraduate at Stanford, grew up in rural Oregon. My plan was to be a veterinarian. I was studying biology, but I've been always interested in other things and kind of being able to learn about areas that I wasn't, found interesting, self-taught in computers, a little bit of math. And I wrote to Marty Hellman saying, hey, I'm interested in this thing about cryptography. And after talking with one of his grad students, he welcomed me into this world of people who were thinking about cryptography and its impact in the real world. And if it weren't for them, I would be a veterinarian right now. And depending on how much you like animals and how many headaches you've had from side channel attacks, you can decide whether that's a good thing or bad thing. But I'm here and I'm not working in a vet clinic right now. And I've super, super enjoyed being a part of this world. And I want to point out that wouldn't have happened in most fields. In most places, there would have been barriers to people coming in. There would have been ideas that were too opaque to understand. Part of this is an accident in history where we had EE and computer science and math all kind of coming together. So a sort of a wayward veterinarian didn't really seem as different as maybe would have been in some other places, but that's only a little bit of it. The real big part of it is that we had a group of people in this world who were inviting and are inviting and made it a place where I've really enjoyed working and having some fun with folks. Some of the folks I've had fun with I want to shout out to. One is the cryptography research Rambus team that I worked with for many years, and also the people who entrusted us with real world problems, because kind of the grist for real world research is understanding what customers need or why systems are failing. And I'm somebody who loves the real world stuff. I think Vincent called it the swamp of dirty practices. So I'm not sure what that says about me, but I really, really love those kinds of problems and was really lucky to be handed a bunch of them. And it still seems super weird to me that you can make money doing this. I'm not quite sure how the world aligned, but that worked out. I also want to call out the co-authors and people whose work I built on, and also the great work that's been done since, because research is really one link in a chain or in a web, and no idea stands by itself. It's really just a part of a long series. But as trying to think of what to say, I went on Google Scholar and pulled up the 3 papers Dan mentioned, and there were 18,000 citations for them, and I had no idea. And I lost my entire day looking at really great work other people had done, which is partly why I'm a little bit scattered right now, as I was doing that instead of preparing these comments. But when I think about that, just like the tiny, tiny percentage of the work that I did was also super humbling, because it's a lot of you who've cleaned up code bases and dealt with these messes that really all I sort of did at some level was to say, hey, way over there, 100 miles outside of town, there's an evil monster living in a cave. And folks could have just said, okay, there's an evil monster in the cave, I'm going to keep doing my thing. But this was the community that kind of rode off on horseback and tackled some of those monsters. I'll come back to that in just a second. But it was the folks in this room who did almost all of the work, and I did 3 papers. So I probably shouldn't be getting the award. I should be chopping it up into hundreds of pieces and giving you little bits of it, but it's too pretty, so I'm not going to do that. Another little sort of interesting story, and right after I presented the timing attack paper at Crypto 90 something, this was a long time ago, somebody in a really friendly way says, really great paper. This was after I gave my presentation, but it's an engineering paper, not a crypto paper. And that comment sort of stuck with me. And now that I think about it with a little more time, I actually think at the time it was true. It was an engineering paper, but it was the crypto folks who took up the challenge. It wasn't the electrical engineers, it was the crypto folks that went out and I would say tackled that monster, but it turns out there's a whole lot of different monsters, and we have a whole biology of monsters and different terminology for how to deal with monsters and boxes to contain them. And it's been this community that's done all of that really hard work. And it again, didn't have to be this world. So thank you to all of you here. And I'm actually really super proud, more than of the work, but actually how the community has kind of rallied around and expanded the definition of what cryptography is. And when I say crypto, I mean cryptography, not cryptocurrency, to capture this sort of broader idea. And I think today those would be viewed as, that would be viewed as a normal crypto paper to have. When I look to the future, though, of kind of where we're headed, I think it's super bright, but kind of in a dark way, because it's like telling somebody who's working in infectious diseases that their future is really bright. But there's this expanding frontier of technology, and that obviously creates more territory for us to analyze and to try to protect. But crypto is the one thing that works, right? We have all these other things that really haven't been nearly as effective. So we've got this sort of unique tool set for tackling those problems. But that's also a really big burden for a tiny community. And we have to tackle a lot of these challenges that we don't have other tools, but where cryptography and the math associated with it has some chance of being effective. So in some ways, maybe the biggest legacy of the side channel work isn't actually the papers, but the people that responded to them, and the community that expanded and is now able to handle these even bigger problems that are going to be coming along as these frontiers keep expanding out, and being ready to tackle those new monsters as they come along. Now, I want to point out that expansion isn't just new subjects. It's also about making the community more diverse, including people with different backgrounds and perspectives. I've come to this world as kind of an outsider. I don't think there's anybody else here who just has an undergrad degree in biology. So, but the fact that it's welcoming of outsiders gives me a little bit of hope that maybe for even some of the bigger, broader diversity questions that we have to tackle and people are tackling, that our community is going to be more prepared to deal with that and embrace that than some others. So as I look forward to the future, it's obviously going to be messy, but the things that we do can determine whether we have really messy outcomes or less messy outcomes. It's the same as medicine. You're not going to make all people healthy all the time, but it has a huge impact. And that's really what real world cryptography is about. It's about the stories we tell. It's about how those stories shift our mental models. And I'm kind of honored that some of the papers that I wrote maybe shifted our mental models a little bit and changed the way that we look at how computer systems work. And even with the case of the Spectre paper, which has, I don't think there's any mention of cryptography really in the whole paper, but it's the folks in this community that really took up the challenge in many cases of trying to figure out what the solutions might look like. More so, for example, many times than the microprocessor people, who really were the ones living right next to that particular dragon. So, when I look forward 20 years, I'm really looking forward to hearing what is our definition of cryptography and how all of us are going to shape that, and what's this world going to look like. And I'm super having a great time being part of it, and thank you all for making it so much fun.
Awesome. All right, great. So with that, let me just end by saying that the Levchin Prize for Real World Crypto 2024 is seeking nominations. You can find the nomination page on the RWC website. So if you have an idea for someone who has had a big impact on the practice of cryptography in the real world, please submit a nomination. We encourage all of you to submit. Although I would say that we already have plenty of nominations for Satoshi Nakamoto, so please don't nominate him again. Okay, so with that, we'll end, and everyone enjoy your lunch. Thank you.